Okay, I guess we'll have to start. This is 2:16 already. Okay, good afternoon, everyone. My name is Michael. I'm going to be the host for today's event. And today we have the Python Meetup. Can everyone hear me? Can you guys hear me? Please confirm, can you hear me?
Yes, I can hear you.
Okay, thank you. So this is the Python Meetup, the Data Science Meetup. And we have two speakers who will be speaking with us, who will be speaking to us. Sorry, just a moment. Okay, so our first speaker, graduate of computer science from Medina University, and is a full stack developer in Python at BincomDevCenter. His name is Onah-ojobo. I hope I got that right, Efe.
Yes, you do. Yes,
Okay,
you do.
make your presentation with us.
Ted?
So you can go ahead now. You have the floor.
Okay, let me share my screen. So, good day, guys. Am I audible?
Yes, I can hear you.
Okay, so my name is Onah-ojobo. So I'll be talking on data acquisition before the second speaker comes to speak on data life cycle. So basically, I would like to start my presentation like this. I would like to divide my presentation into what is data and what is acquisition before we can now join the two words together to talk about what is data acquisition.
Sorry to cut you. Can you please turn on your camera?
Okay, 1 minute. Yes. Can you see? I've turned it on. It's on now. So,
Yes, it's on, but the background is not very clear. But you can go ahead and share your screen.
okay. So, like I said earlier, I would like to start my presentation by dividing what is data and looking at what is acquisition. Then, at the end of the day, we'll now fuse the two words together to understand what is data acquisition. So, I would go like this and start. What's data? From our own understanding, or basically from we that are inclined as an IT, we come to understand that data are a set of value of quantitative or qualitative variables about someone or about an entity. And we could also say that data is an information that can be translated into an efficient form.
Sorry, I can't hear you clearly.
Can you hear me now?
Yeah, your
can you hear
voice.
me now?
Yes, it's
can you hear me now?
It's better now.
Damn it, I went to be shouting. So like we can see in the definition that data are a set of values of qualitative and quantitative variables about one or more person or object. Data can also be defined as an information that has been translated into a form that is efficient for movement or processing. So this is like a rough view about understanding what data is. So in essence, now what may play in our mind is that when we say data, what do we mean by qualitative data or quantitative data? Now,
I think your
qualitative data.
Sorry, I think your screen is paused. I can only see data I'm still seeing the first slide. I don't know if it's the case with the
I've-
other person.
I've moved. I just moved it now.
You can only see
I'm in
the first
qualitative.
slide.
Maybe it's
Check if
network.
your
I've
screen is
moved it.
paused or something.
No, it's not paused. I'm still sharing. It's still showing sharing. But let me pause now. Let me stop and share again. Let me stop and share again. Can you see my screen now? Can you see my screen?
Yes, I can't.
Okay. So I was already in data, already in qualitative data, because initially I said that data are set of values, qualitative and quantitative variables about one or more person or object. Can you see this part?
The
Is my screen
qualitative,
moving now?
I can see the qualitative data slide.
Okay. Okay, now I'm going to qualitative data now. And I said qualitative data because we're trying to understand what is this when we say qualitative data and quantitative data. What do we mean by that? Because understanding this will give us an overview or a paradigm shift about what data acquisition is. So now when you say qualitative data, these are non-numerical data such as text, video, or photograph or audio. So these data are basically qualitative data are basically represented in a video format, and they are non-numerical. Anything non-numerical data are seen as qualitative data, and they are basically the way you can get qualitative data basically by observation or by the use of words, and qualitative data basically involve the use of our five senses, and from our primary school or from when we are young, we know that when they say what are our five senses, we talk about the eyes, the nose, the tongue, the ear, and the skin. Now, in terms of qualitative data, like I said, eye is used when you talk about eye. In terms of qualitative data, you are talking about probably what data are you trying to get? Is it color? Is it color? When you talk about nose, basically you say what data can you see? So in essence, you can say maybe probably color, a color of chair, a color of car, whatever color you can see, you know what to write that down in terms of recording your data. When you talk about nose, you're talking about smell. Where in your surrounding, does this smell bad? Or any chemical you are titrating, if you're a chemical student, does that chemical gives you the desired smell you want to give? Or when you talk about tongue, you're talking about taste. So it means that whatever you are tasting, is it good or not? So these are ways by which data are being recorded when you are using when you're talking about qualitative data. And like if you look down, I said example of qualitative data, air colors of players on a football team. So this data you are visualizing it. It's not numerical. Just basically just visualizing it. These are air colors of particular players in a football team. Or you can say grades of students in a classroom, color of cars in a parking lot. Exactly. Fine. The next data type of data we're going to move is qualitative data. And quantitative data is opposite of qualitative data in the sense that we know that qualitative data does not do with numeric. It does basically it's like a decrease. We just get our data by observation using the five sensitive organs, like I earlier said. And when you come to quantitative data, it focuses more on numerical data, how your data works with values and how you can use values to express or generate your particular data. And in qualitative data, it focuses on two major type of ways of getting your data, or two major type of numeric type. You have the discrete and the continuous. And most times, and when you talk about the district, it's what we call counting of numbers, which means that any number you are counting must be a discrete value. So when you say discrete, it must be at that exact, must be an whole number or that exact value. And if you look at my example here, I said if you are counting an animal, let's assume say cats. You can't say if you have 8 cats, you can't say you have 8.5 cats because it's highly impossible for you to have 8.5 cats. But you can have 8 cats, you can have 7 cats, but you cannot have 7.5 So when you talk about this, you say, give me that exact number, that data. You want it as a whole number. That's why we can see that you can only have 8 cards, but you cannot have 8.5 cards. That's when you're talking about discrete in terms of gathering discrete data in terms of quantitative data. So next, we're going to talk about continuous data, which is still under quantitative data. Is based on measurement. Don't forget that we are looking at this process so that we will to understand when we get to data acquisition, we will to understand what kind of data acquisition is taking. Is it taking a quantitative data or is it taking a qualitative data? So that when we get there, we will
Sorry,
not have
Efe.
it. Hello?
Sorry to keep
Can you hear
cutting
me?
you. Yes, I can hear you, but I just want to confirm if I'm the only one having this problem or if it is general, because I can still see the third slide, and I guess you've moved to the fifth slide, right?
Yes.
I'm still seeing the third slide. Is it the same for every other person? Can you guys confirm, please?
Same here.
Okay. If I guess the issues from your end, we're still seeing the third slide.
Probably you have network issue. I'm missing my data. Okay, let me stop and share it again. So I'm using my personal data because I cannot connect to the office network. Let me stop and share again. We have an issue. My network issue. Yeah, that was on, yeah. And I cannot connect to the office network. Can you see my screen now again?
Yes, I can
Hello.
see it. I can see it. It's currently on the fifth slide.
So, let me. Okay, so let me. Where were you not? Where did I stop? So I will start again from that side. Were you on the third slide? Were you viewing the third slide? Third slide, Abby? Hello, can you hear
Continuous
me?
data.
Continuous data, okay. Continuous data. Let me just start from there. So let me just go back a little. So I was talking about quantitative data. We are seeing qualitative data. So I was talking about quantitative data. We saw that when we're talking about qualitative data, we're talking about non-numerical data that we are getting. When we are talking about quantitative data, we are talking about numerical data that we are getting using numerical form. You get so in quantitative data, you get your data by using it can either be in a discrete or continuous form. And we understood that when you're talking about discrete data, it involves what counting in the sense that you are going to be counting numbers. And when you're talking about district, district talks about getting an whole number. There's not like decimal in a district number, in the sense that you cannot say that if you're having 5 cards, if you say, okay, I have 5.5 cards. No, it must either be 5 cards or not, or 0 cards. So discrete data does not accept decimal notation in their number. Their numbers must be discrete. You get, so that is just it. So I said in general, discrete values deals with whole numbers. So therefore, you cannot have 8.5 cards, but you can only have 8 cards. Same with the house. So it deals with an whole number. That is just it. So another form of quantitative data, I was saying that while we are looking at all these steps, is for us to understand when we get to when we get to data acquisition, we understand, okay, what type of data is data acquisition taking? Is it a quantitative data or a qualitative data? So now when we talk about continuous data now, it is talking about measurement. It's based on measurement, meaning that something that can be measured, in a numerical form. So now, I believe that some of us are here as science students, or if you're not a science student, there's what we call in science, what we call distance equals a change in velocity all over time taken. So now it talks about change. When it talks about how will I put it now? It's talking about, okay, what is the distance by which it will take A to reach B? So that is the distance. That's what it's talking about. Distance equals to change in velocity. It's present state. 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 It's present state, at that present state of A, what will it take, or what will be the distance for A taking to get to B? So what is that distance between A and B? So it talks about that present change in state, and which can be represented. So one beautiful thing about continuous data is that it can either be in an whole number or in a decimal notation. That's why if you look at it, I said that 200 kilometers or 7.7 meters. So you can either express it in that format when you're talking about continuous data, because while it's continuous and dealing with a measurement. So another form of continuous data which you can also deals with measurement is temperature of an object or an entity. An entity says that you can check your body temperature if you're going to answer, and most times they are always probably in decimal notation or in whole number. Also speed. What is the speed of a moving car? So there's a change in state. It's covering a particular distance. And also, what's the weight of a body? Now, I can be having 400 kg. So I can be having 400 kg in a month of May. And if I do my series of exercise, my 400 kg can now be reduced to 20 kg. So there's already a change in state. So their data, it's not like a fixed data. So that's basically what continuous data under quantitative data means. So in general, when data is processed, organized, structured, and presented in a context so that it can be used, it is called information. So remember that all these things we are trying to process is as a result that we can get a certain information. Like I'm assuming like I'm sick now, I'm going to the hospital now, I want to go and check my temperature. So by checking my temperature, that the doctor will now be able to process, okay, if my temperature is below the normal temperature of which a body should get, it might become that you are sick. So that is the information that has been processed out. So if my body temperature is normal, the information that the doctor may give that, okay, your body temperature is normal, you don't need any medicine, just go and take your rest. So all these process by which you are taking is what get an end result, and that end result is what we call information. So now, like we have previously seen, what are the major two types of data? We say quantitative data and we said qualitative data. Hope I'm audible. Hope I'm audible.
Yes, you are, but I can't tell if you've moved to a different slide because I'm still seeing the fifth one. Are you still on the fifth slide?
No, I've moved on that slide. I'm now in types of data.
I think you'd have to be selecting the slides with your mouse instead of using the cursor buttons, the arrow buttons.
Oh,
yeah, let's see if
okay.
that works.
So I will stop. I have to stop. Okay.
No, you don't have to stop sharing. Yes.
Like this, Abby?
Yes, like that.
You can see this now, Abby?
Yeah, I can see the seventh slide.
Yeah. So and that's like we have previously seen, types of data. We've seen that quantitative and qualitative are the major forms of data collection. So basically the way you gather data are just either you can gather it in a qualitative manner or in a quantitative manner. So this quantitative manner is not okay. Once I've gathered my data in that, what the is you can do, and if I've gathered my data in a qualitative manner, what I want to do is just that the major ways by which you gather data to use for processing, whether you gather it in a qualitative manner or in a quantitative manner. So in next slide, you can like I said, 7 ways of collecting data: survey, online tracking, transaction data, and so on. These are just 7 ways by which it's not is 7 ways by which you can gather data. Yes, so that is just it. Now, after all this, now we now move on to data acquisition. So it's an act of acquiring all this data and processing and use them to do whatever you want to do. So acquisition is just about acquiring, an act of acquiring, just to acquire something. So with that, we can now move to what we call data acquisition. Now, what is data acquisition? We are seeing that what is data, we are seeing what data is and the way by which we can gather data and what acquisition is. So now, what is now data acquisition? This is the process of sampling signals that measures real-world physical conditions and converting that result sample into digital numeric values that can be manipulated by the computer. Okay, so now, from this understanding, we can see that we are gathering data by what quantitative, and then by the means of quantitative, because we are our data is basically changing in state. You can see converting samples, real-time physical conditions. So most of the time, when we are gathering data in data acquisition, we are using most of the time quantitative and quantitative data process. Exactly. So data acquisition can also have an acronym for that, which is also basically called data acquisition system. It's used to basically convert analog waveform into digital values for processing. So basically, yeah, that data has been converted into what we call information. So that is just basically it. So in general, that is a system for data processing, data conversion, data transmission, and data display, and then store the data. After data has been processed, after you have gotten your data, normally when we say data is like a raw format, it comes in a raw format, and that format you now process it, and that form of processing you can now use it to do whatever you want to do. And once you have processed and you have given out, and that information has been given out, you can now store it either in a database or whatever storage system you want to store the data. So these are just the processing in general. That basically, and whenever that we see data acquisition system, basically you process the data. Once you have accepted that data, you need to now process it. And once that data has been processed, you now convert it, then do what we call data transmission. After you have done your data transmission, you will now do display of that data. As we move on, I will show you a graph that talks about the entire architecture of a data structure. Now, what are components of data acquisition? We have what we call the sensor, we have what we call the signal condition circuit, we have what we call the analog to digital converter. So we can see that the sensor is used to what convert physical parameter of data, in the sense that a state, when you talk about physical, it means the data. What data are you reading in? It's converting that data into a scenario. Let us assume I want to a speedometer now, or to get not a speedometer. I'm trying to remember the instrument used to get to the read when you have something like all this tumbling wind. Basically, you use that forgotten the meter name. You use that meter to check the pressure of an hurricane. So once you've checked the pressure of an hurricane, that it reads it and that gives you a particular reading of this is the level of that hurricane. I don't know. So it's like a sensor. The device is like a sensor that reads when there's an hurricane in a particular geographical area. So it reads the magnitude of that hurricane and gives you that result. Okay, this is the magnitude of this particular hurricane that is currently blowing right now. So that's what basically how you read data in. So you can read by sense by using what called a sensor, and basically these are all processes that which to give your desire and your final output. So now this is the graph I wanted to show you. So that this is your transition, which is like the inputs that you are sending in. And if you look at the process, the formal process we said, this is like a transistor. You are going to accept your data and process your data, and this is it here. You are taking this your data, and you are now process what we call passing it into this your condition, and which your analog signal, which accepts your data. And this multiplexer is just like you're plugging all your data into one source, and then once you plug into one source, this is your converter here that converts your data. It converts your data for you, and either it now displays for you print digital display, magnetic tape. So it gives you your this place here you are seeing here. This place you are seeing here is called your final output. So this is basically the process by which you can get your data once you are using what we call digital acquisition system. So the next phase that we want us to look at is we need to know that we have application that we have application we have app- we need to know that we have application developed in order to carry out data acquisition, and these applications are usually controlled by programmers developed using various general purpose programming languages such as assembly, basics, C, C++, C pound sign, Fortran, Java, Lisp, and the rest. So basically, in order for you to make use of make use of data acquisition, is basically it's been developed using all these programming language. You can use all I put it, there are programs that are being made exactly for you to do what we call data acquisition or perform some processes using data acquisition, and these are the programs who are totally dedicated for that purpose. So we say in data acquisition, we have what we call standalone system. Standalone systems are often called loggers. They are also open source packages provide, providing all necessary tools to acquire data for different hardware equipment. So in the sense that we use so in general this aspect of data acquisition and logger which we use to what and provide other packages in order for us to make use of data acquisition. So in conclusion, data acquisition system plays a major role in data processing in today's world, and this cannot be overemphasized. So, thank you very much for listening.
All right, thank you very much for that presentation. Next, we have the second speaker. We have Taoheed Abdulraheem, who is currently a computer science student at Federal University of Technology, Mina. He's a data analyst and machine learning enthusiast, having worked on data science projects both alone and collaboratively, and is passionate about teaching and bringing others into the data room. So, Taoheed, are you here with us? Okay, so you're muted. We can't hear you.
Okay. Good. Can you hear me now?
Yes, I can hear you. You can go ahead.
Okay. Yeah. My name is Taoheed Abdulraheem. As I said, I'm a data analyst, a junior data analyst at Advanced Engineering Innovation Research Group in FET Mina, and I'm currently a computer science student, as I said, and I'm a machine learning enthusiast also. So now I will be presenting my slides to you now. So
sorry, Efe, can you stop sharing so that you'll be able to share his?
You said what?
Kindly stop sharing your screen so that Abdulrahim will be able to share his.
Okay.
Yes.
Sure.
okay. Be able to, yeah. So out. Okay. Yes. Today I would be speaking on data science life cycle, as that is my topic for today. So as I said earlier, I'm a junior data analyst at ARG in FET Mina, and I'm a machine learning enthusiast also who has worked on data science as project. As I said, I'm a computer science student from FET Mina. So today I will be speaking on the data science lifecycle, but before I start, I would want to brief us through the data science, what it is and what we should know about it. Okay, yeah. So data science is a field which combines multiple fields and which includes statistics, scientific methods, artificial intelligence, and data analysis to extract values from data. So it encompasses preparing data for analysis, cleaning, aggregating, manipulating the data to perform advanced data analysis. So data science is a new field, actually, which it brings about most different fields to make it one. So presently, there is no specific definition for that we can have for data science, because it's just an imagined tech field. So what people have concluded about is, because it includes statistics, it includes AI, it includes data analysis and all sorts. So that is what part of what has brought about data science. So please, can you hear me? Hello?
Yes, I can hear you. Can hear you.
Can you hear me?
I can hear you. Hello, Abdulraheem, I can hear you. Hello, are you still there? Hello, Abdulraheem, are you still there?
Can you hear me?
Yes, I can hear you. It's like you dropped off for a moment then.
Yeah, because I didn't get the response, so I will start again. Can you see my screen?
Yes, I can.
Okay, yeah, good. So I need to hide this. Okay, yeah. So as I said earlier, data science is a new field in tech, which combines different fields also, which includes the statistics, which includes scientific methods, it's artificial intelligence, data analysis, and all sorts. Because it's an emerging tech space that is actually causing a wave. Because so most of the data science does not have a specific definition for now, but this is what has been agreed on by some experts for now, which is a field of such. So, okay, yeah. So, who is a data scientist? A data scientist is someone who is a data expert, analytical data expert, who works on data sets that to solve complex problems. Complex problems can come in maybe business, maybe finance, maybe perhaps health sectors, and all sorts. Also, a data scientist is someone who is very curious. Should be someone who is very curious, because you have to know how these data can be manipulated to work for what you need it for. So a data scientist is basically that. And what are the must have skills for a data scientist? Yes, you must have, there should be one, technical skills and non-technical skills. Technical skills in the sense that you must know how to code. So under coding, you should have a knowledge about perhaps a programming language. For now, I think the two most common programming languages for coding for data science is Python and R. So that is where the coding aspect comes in. So you must be able to code in either Python or R for flexibility, though. So you can choose to use, I think JavaScript is currently supporting data science, like some of the models, the packages in Python and R, but it is not basically the generally accepted programming language for data science. So the general ones are just Python and R programming language. So for the SQL, you must have SQL knowledge also. Yeah, this is where in the real world data can be are either stored in databases. So that's where the SQL, because SQL is the is like, should I say, a general platform where data sets can be stored. So it's you can have the MySQL, you can have MySQL, you can have the Apache and all sort of SQL knowledge. So you must have you must be able to manipulate data using the SQL language of your choice. So also you must have a technical skill of machine learning and deep learning. Machine learning and deep learning in the sense that sometimes using machine learning can actually work for some data sets when you are working on them, and why some are deep, why some requires deep learning. Machine learning uses can take a little data set to create on a, and you create an algorithm, it works on data and give you the output. Why deep learning works on a far larger data set, so you'll be able to bring in a much more data set and give you almost accurate prediction. So also you must have a skill, you must have a good skill in data visualization. This is where, mostly if you have a client that tells you, please, I have a data set, give me, what can you give me out of this? So you can't present your codes to the client that, okay, this is what I've done so far. You have to visualize and tell them, okay, this is the prospective way of what your data is going to, or how you think this can help. So data visualization is a skill, is a must have skill for data scientists. And also for the non-technical skill, a data scientist must be curious. You must be curious to know what and how a data set can lead to this. How do you think this can help? And also a data scientist must have a business mind, in the sense that having a business, you might end up in a place where it is not basically health sector, or in maybe.
Hello, Abdulraheem, are you still with us? Hello, Abdulraheem. Apologies, I think Abdulraheem is off the call, probably due to network. Let's just allow him some time to rejoin.
I'm sorry, please. My internet has been coming on and off, but I would join now. Please, can I confirm that you can hear me?
Yes, I can hear you.
Yeah, please. I will be using my phone from now. I just need to get the link to my presentation. My internet has been far from okay. I'm with you. Okay, so it's coming. I would share my screen now, and yeah, I would share my screen now. Okay. I can. I'm sorry for the delay. I'm sorry for the delay. I want to confirm if it is sharing the screen. Can you see my screen now, please?
No, not yet.
Okay. I'm unable to share my screen for now. Oh, this is serious. I'll be with you shortly, please. Can you see now?
No, I can't. Okay, it came on briefly and then stopped.
Yeah. Okay, it came on briefly now.
Yes.
Oh, please, can you type in the meeting link for the meeting passcode for me in the chat box, so I can present right from Google Slides. Thank you.
Or you know what? You can actually, if you have the link to your presentation, you can drop it. Then I'll share it for you.
Okay. Wow, that would be better. That would be better. That would be
Just
better.
drop the link in the chat section. Then I'll continue from where you stopped.
Yeah. Let me copy the link. I'm still trying to. Oh my God. Copy link. Okay, yeah. I'm sending it to the chat now. Have you received it?
Yes, I have.
Yeah. Okay.
Just a moment.
Yeah. Are you live? Oh. Can you present?
Yes, I'm about to.
Okay. Is it coming up?
Yes. Can you see my screen?
Um,
Is my screen visible?
it's It's loading.
Okay.
It's loading. Okay, yeah. The next slide. You can click on the slideshow next to it. At the top right
Yeah,
corner.
it's still coming up.
Okay. Yeah. Okay. Okay, so I'm sorry for the delay in for now. Okay, so I would continue from where I stopped. Yeah, next slide. Next slide. Yeah. So yes, no, previous slide. Yeah, thank you. So as I was saying, I said a data scientist must have two basic skills, which can be classified into technical and non-technical skills. So I explained that you must have a coding knowledge, perhaps one of the major data science languages, which is Python or R for data science. Yeah, and also you must have a SQL knowledge, perhaps, which because it is SQL is mainly where data are stored. So maybe MySQL or Apache or any other SQL language that you can use to access your data set. So also you must have a skill in, you must know ML and DL well. That is machine learning and deep learning. Machine learning in the sense that sometimes you may have your data sets might just be something small that you need a little data set for. Machine learning works on does not require a lot of data sets. So your accuracy might drop down and you might not have a better prediction. So that is where your machine learning skill will come in. So sometimes you don't use ML, and DL is when you have a larger data set that can accommodate a lot of data set, and it increases with the larger data set, the higher your accuracy of prediction. So also you must have data visualization skill, because after writing all your codes in your perhaps your Google Colab or offline using your Jupyter Notebook or any other environment, you need to visualize. This is when you plot graphs or show trends in how the particular problem is going. So you must have that visualization skill. So also in non-technical skills, a data scientist must be curious. So you must be able to think of, okay, how did this happen? How can I make this? Like, you must have that that curiosity mind in knowing that, okay, this is how this should be. You must be business oriented also, because sometimes you might not find yourself in the health sector, perhaps in a business environment. So you must have that zeal to, okay, how can I increase our sales, the demand of our products, and also you must have effective communication skills. You must be able to have teamwork. You must be able to work in teams, because you won't be working alone. Yes, you will be working alone. And also you must have access to resources. Access to resources in the sense that as you need to make an example about a data set, you can use Cargo or Google Data Search, and also you must have and also you must be well oriented with your GitHub different repos where you can access when people that have worked on all sort of on all sort of problems before. Please, next slide. Yes. Next slide. Yeah. Okay. So to my main topic for today, which is data science life cycle. Data science life cycle is actually a cycle which includes steps, iterative steps that a project must follow before it can be delivered, or before it can be submitted as a finished piece. So a data science lifecycle is not something that it's not just a one lane type of a field. So you would sometimes you have to go back to some previous step. That's where iterative comes in. You might have to go back to some previous step and to retrace your step and make better outcome of what your preferred output should be. So it's a set of iterative steps that a project must take to follow. So individuals, like I said in the previous slide, which says you must have teamwork, like you must have that skill of teamwork. So individuals, there are a lot of people that should be involved in the data science project. One, you have a business analyst. If you find yourself in a business environment, you must have a data analyst, a data engineer, an ML engineer, and all sorts people that you'll be working with throughout the project data lifecycle. So please, next slide. Next slide shows us about the stages of a data science lifecycle. One, you must have the domain knowledge. I think that will, please, next slide. Hello. Yeah, so I think there is an error in the first one. The first one should be domain understanding. It shouldn't be business understanding, because if I say business understanding, I've already secluded it to the business world. So domain understanding, we have data collection and preparation, we have modeling, and we have the model deployment. Next slide. Yeah, the first one I'll be talking about is the domain understanding. Next. Domain understanding is like it is you as a data scientist, when you are brought into a field to come and express your area of expertise in a particular sector, you must have, you can't just come into a field, perhaps you're a data analyst, and they said, okay, there's this disease that should be coming up, and then we'll be giving you different data sets on symptoms. So you should predict what type of disease will be the next. So without you having a basic understanding of how the health sector works, you can't just start working on a disease data set. Get? So you must have a basic knowledge of the domain you are working on. You must understand the problem. Yes, you must also understand the problem, because understanding the problem solves perhaps 30% of what you have to do. If you understand the problem, you know what part to take and what part not to take. Also, you must take consultation from domain experts, people who are experts in the field, perhaps the CEO, or people people working in the particular environment. Okay, this is what we need. Perhaps you are working at a shoe factory, and you are told, please, how do you think we can increase our shoe sales in our environment? So you must be able to ask questions from people who have been working there. Okay, how do you think, what caused the surge during this period? What is the challenges we are facing? What are challenges we are facing, and all sorts? Okay, you must be able to ask required questions, like essential questions from the clients or the stakeholders of the company or the group you are working with. So this will even enlighten you more about, okay, what could have been the likely problem of you not making sales? What could be the real cause of the next disease that will be out, or any other business question, any other questions that is important. Yeah. Also, after having the domain knowledge, then the next is data collection and preparation. Next slide. Data collection and preparation. Yeah, I think the previous speaker did justice to that. He did justice to that, because he explained how data can be acquired, and I believe so. I'll just brush through all others because it won't be like I'm repeating what he has done. So yes, there are different ways to collect data. Yeah, data collection is like a way of you bringing in data sets that, please, or bringing in data that you will require for your project. Yeah, you can. There are forms that you can bring in data sets. You can use web scraping. That is when you go to website and use your web scraping skills to extract data from each website. So you can extract it also through third-party API by acquiring that. And then that is just mainly about data collection for you to acquire your data. For the preparation, you need to clean your data or data wrangling. This is where data cleaning and data wrangling is when you are able to make, for example, because in the real world, data sets are not always clean. Like sometimes you see where there should be numbers, there will be letters. Where there should be numbers, there will be alphabets. Where there should be alphabet, there will be numbers or blank spaces. So that is mainly where data cleaning comes in. So you'll be able to extract the features that you'll be able to clean the data, make every column or every row be distinct in all ramifications. So data cleaning or data wrangling is what that is all about. It's actually a topic on its own also. So
The next one is the EDA, that is exploratory data analysis. This is when when you'll be able to visualize your data. Maybe maybe a pie chart, a bar chart, a real-time analysis. So you'll be able to know, okay, this is what your data set will be working on, is how you think you can improve and all sorts. Yes. So that is mainly about data collection. So now we've talked about the domain understanding, which is important for you to know. You must have a domain understanding and all that. And also you must have ability to, you must be able to collect your data and prepare them. Sometimes the group you are working with might have their data sets with them. So you will need to go through scraping another person's website or extracting through any other API. So the company might provide you with their own data set. For example, if in a shoe company that for example, I'll use Nike and Adidas, for example. So you can, as a data, if you are called upon by Nike to at least, okay, can you help us project how we can make more sales and against our competitors, Adidas. So you can't expect Nike to ask Adidas that, okay, please, we need your data set that we use to project our sales forecast. So that is not right. So because Nike already has their own data set, so that's what you'll be able to work on. So then you don't need any other data set from an external source. So after that, then after preparation and data collection, the next one will be modeling. That is where modeling is please next slide. Yes, modeling is when your data set has been cleaned, everything has been done. Then you have to write your code to have an algorithm where it will work on. So it is important to decide on the appropriate model to use. If you'll be using the machine learning approach, that's the traditional approach, you can use, there are different types. You have the classification, you have the regression analysis, we have clustering. We have I want to recollect the name for that. I think I think if I give a letter, I would remember, I will call it the name. Okay, so you have to decide on the model to use. You will be using the machine learning approach or a deep learning approach. Yeah, so it's important. Also, you must have to do your feature engineering. That is also that it is applicable in both in machine learning approach, because you would have to select, you have to fine-tune your data set to fit what you want to work on. For example, you might be working on a binary data set, on a binary output. Perhaps if a disease would kill or it won't, if a disease will be lethal or not. So that's just a two-based distance. So you have to feature, you have to extract the data in a way that it will be able to fit into that kind of approach. So also tuning the hyperparameters during modeling, that is used for deep learning approach. Yeah, if you tune your hyperparameter, that is when you use the some of the deep learning skills, some of the deep learning parameters for you to tune your data set. And then the next one will be for you to build your model. After everything has been done, you have to build your model, your algorithm, and then that would bring in everything you've worked on so far. And also, you have to evaluate the performance. You might use the F1 score for classification. There are different evaluation techniques that you can use, depending if it's machine learning or deep learning. So, yeah, during evaluation and performance, during evaluation of the performance of your algorithm, your data set, you might realize that, okay, this model has not gotten to what I need to do. So sometimes it might be a shortage of data sets. Then you have to go back to cleaning, to acquiring your data sets, your data set that you use. So you might have to go back, then clean again, go through the preparation and then remodel. Sometimes it might not be about it might be okay, you might have an accurate data set that you need, but you have to go through the feature engineering. The feature engineering where you would edit, where you would wrangle with data all over again, switch some parameters and also to fit into what you need to do. So that is where the iteration step comes in. So it's not just a straight line. Sometimes you have to go back, because I've worked on a lot of data set that it's not just about me when going through the data acquiring and then the data wrangling model and everything works well. So most to check on what I've done so far. So yes, and then the next one, so far, the next one is the model deployment. So far we know that we've been able to, once we understand the domain, then we're able to collect data and prepare, and also we're able to model our data sets after having decided on what approach to use, the feature engineering, the tool parameters, and then we've built the models and evaluated the performance. Then it is next to deploy our data set. Deploy, once everything that you've been doing so far is only in your environment, maybe your Google Colab or your Cargo workspace or your I think Microsoft Azure also has an environment for writing data science projects. If it's made online or offline using your Jupyter Notebook or your Jupyter Lab, everything we've been doing so far has been existing in our environment. So deployment is you bringing in everything you've done into maybe where it needs to work on, because your model cannot work on you can only evaluate the progress of everything you've worked on, but you making sure it is working well, it has to be deployed on something. So there are three main ways that deployment can occur. It can be deployed it can be deployed as web service. This is when your model is built to work on websites. Yeah. An example of a web service machine learning model is we all know our activities. Yeah. So I think for 3 to 4 months now, it has been mandatory for all websites to pop up if you visit a new website, it will pop up something like these websites accept catch as our cookies. So that is one of the ways, one of the models. There are models working underneath that will track everything we've been doing on the website. So it will accumulate to fit to what you like or things you love. So the models written here are deployed as a web service. So they are deployed on the website and it can work there. The next one is offline models. These are sometimes that use mobile apps I'll use games as an example, or yes, games as an example. If you work on games, if you play some games on your system or on your phone, that which is not an online game base. So there are models that work behind the scenes that makes some things work for you. Sometimes you have access to things another person doesn't have access to. So this is working in batches. So it works offline, and it is running the evaluation task that has been inputted with the model. So the next one is embedded models. Embedded models works these days. I think in electronics, people don't really start with drawing board and breadboard, and also we have something called Arduino. Arduino does not Arduino is a component that like complete component where you don't need to start soldering anything together again. You can just copy your model, paste it in, though it has a maximum capacity that it can take. So embedded models you can fit your your models into the Arduino board, and it will be able to work well. So that is where deployment comes in. And also, next slide, please. Hello. Okay, yeah. So the next one will be where ML models can be deployed. Yeah, this is important because one, you won't have all the time to really always check your models, how they are performing. So if you have, even if you have the time, you might not be accurately, because sometimes your models might have millions of users. Yes, so you can't, if perhaps I have the model was deployed on a website, so and I am using the website currently, it's not possible for you to track my activity and then the next person making use of that website in which the model is running on. So it is important to have a where you can upload your models, and it will be, you'll be able to track and know how well it is doing. So one way where you can deploy your models, one is Google Cloud. Google Cloud, I think, has a very robust way where you can upload your data sets. The second one is the Amazon Web Service. So Amazon Web Service uses Lambda as an environment for you to upload your to deploy your models. You can also use Heroku. Heroku is beginner friendly platform. Also, you can use Microsoft Azure. You can use the not too familiar Algorithmia and Python anyway. So now that we have a basic knowledge of the domain understanding, we know that we know how we can collect our data, we know how we can model, things we need to know during our modeling, and then the model deployment too. So that is just the main steps that a machine learning project should pass through. So you can, sometimes you don't need to, yeah, and also before deployment, you should know that after deployment, things are hard to really work on later. So you must be sure about what your model, your algorithms, it is, if it is perfectly working well. Because once you deploy, you can change things, but it won't be as easy as you changing in your local environment, maybe your Google Colab or your Jupyter Notebook farm. Yeah. And also the next one will be, it's not part of it, but I just added this so it won't seem as you are the boss of yourself. It's the client acceptance. If your clients, yeah, after deploying and everything, you must have this storytelling ability for you to present everything you worked on in a very pleasant way for your client to really know that you know what you're doing. Yes, because you can't work on every project and start showing graphs and the okay, you can tell them, okay, this is what you should do as a company, where how you can make more sales and also. So you must be able to convince the client that this is what I've done and I'm confident about, from the models I've built, this would actually work well for the company or for the organization. So also you must have good human relation with your co-workers if you are to present your work, and also so client acceptance is also one of, and also if your clients should tell you, man, I'm not happy with what you've done, so you have to go back, start all over again, or check out where you were not able to convince your client well. So this is I don't see it as something very important, but it is also required in the data science project for you to for your client to be happy with what you've done so far. So I think I'll be able to make justification about all this. There are, in some ways, some people will be able to, they can list almost 10 or 12 steps, but everything will still come under this four, because instead of you splitting, I've already made a summary of all the cycle that you got, everything will follow that. So it will be one, this the domain understanding. You must understand the domain. Then the next one will be the data collection. After the data collection, maybe the company has their own data set already, or you have to use an external source. And then the preparation, this is where the wrangling comes in, your cleaning comes in and all sorts. And then the modeling, this is when you decide, okay, am I using the machine learning approach or I'm using a deep learning approach? Then you find if you need to make feature engineering, or if you're using a deep learning approach, if you need to fine tune your hyperparameters to fit the data, the what your project, your intended project you'll be working on, and also the deployment. Then that is when you decide, okay, what am I working on? Is the model working on a web service or offline or in an embedded system like Arduino? And also where you'll be deploying your models too. So all these steps are important, and those are the required data science life cycle that I have been able to bring up. So if you have any questions, please, you can let me know.
Okay, thank you very much, Abdulraheem, for that presentation. So now it's the time for questions. If you have questions for either of the speakers, please kind of mute your microphone now and ask. This is the time for questions. If you have questions, kindly unmute your mic, or you can drop the question in the chat box if you do not want to speak out. You can drop the question in the chat section and then I'll read it out. Okay, I have a question for the second speaker. Abdulrahim, can you hear me?
Yes, I can.
Okay, you mentioned earlier that the only languages that are used for data science currently are Python, R, and then although not generally recognized, JavaScript as well. Am I right? Or is it just Java?
Yes, yes.
Okay, going forward, like in the future, how many more languages do you think will come into play when you talk of data science?
Yeah. Every day things are advancing, and everyone is trying to make life more comfortable for each other, for everyone. So I think for now, the two major languages, which are Python and R, have a potential competition, especially from Facebook. Facebook owns JavaScript. So in the future, we might be seeing, I think for now, we still have, I think, three other languages which are also getting accepted in data science community for data science projects. So I can't confirm their name for now, but I think I've met about three. With JavaScript is also one. So JavaScript, I think they started when working on these projects in 2017 or so, but it is not generally accepted because it doesn't have that robust features of Python and R. So in the future, we should be seeing a lot more language that will be able to adopt data science as a platform or as a language for working on. So yes, there's a potential that a lot of languages will be coming up.
Okay, thank you. One more question. What level of expertise or what level of learning does one have to get to in order to embark on data science? Is it beginners or intermediate or expert?
Well, for data science, you can there is no experience limits in you working on a data science project, because this, before now, I think I'm talking about the pre-internet age. Things are hard. You have to read books. You have to go through resource materials before you can learn. But now things are easier. You can just log on to your Coursera or YouTube sometimes, or sign up for a free webinar where you can be taught. So also, you don't need you don't need to be an expert in data science before you can start working on your project. You can visit kaggle.com. Yes, kaggle.com is a very user friendly and a beginner friendly platform where you can learn data science, and there are data sets for you to work on. You can start from the prediction data set or the Titanic data set. So with that, if you start at the base, then you won't even know that you are an expert already or an intermediate developer already before you know that, okay, yes, I can work on a project. So because I also started from Kaggle, and I'm glad it has a really good turn on me based on what I can do for now so far. So you don't need to be very knowledgeable about data science about data, but the basic thing for you is just to have a basic knowledge of Python. It's important. Have a basic knowledge of Python. Then you can learn even SQL languages. You can learn them later. For you, yes, you can learn them later. But if you have a basic knowledge of Python, then you are good to go. You don't need to be an expert or also before you can start a career in data science.
Okay, one more question. Thank you for that reply anyway. You talked about web scraping. I've been hearing web scraping. I don't think I really grasped it when you were explaining. Can you like throw more light on it, on web scraping, what it entails? Hello, did you hear me, Abdulraheem?
Yeah, yes, I do. Web scraping is is like you having, how do I explain? Okay, it is you going to a website. If you feel they have the data set that you need, like what you need from their website, and you writing codes from your own local environment to download the data from their site. Some sites accept, some don't accept. So the web scraping for using web scraping, you will be able to there are different packages in Python for that, for web scraping in Python. So the tools that can be used, I think we have I can't remember the names. Okay, but basically web scraping is you having to download to get data sets from a website into your local computer where you can work on. So, for example, I think I've worked on a a website online where they make food, where they make food and sell. So and on their website you have the type of food, when it is made, where it is delivered, the time it is available, from what time and what time the food is available. So from that, I was able to use my data to use the skills that I have to download, to copy the data sets from their sites into my computer and work on it. Do you understand? So it's not something very hard for you to know. In fact, it's one of the easiest way of acquiring data sets. Why some websites accept, some don't. For one other major platform that accepts web scraping is Twitter. That is where you can analyze tweets using the NLP, natural language processing. And then if, for example, you are trying to work on a cloth and you feel, okay, I think I should get people's opinion about how this clothes should look like. You can have an image, then you would be able, you can extract tweets from Twitter. If you have a developer account with them, you can extract tweets, and the more people are saying, like the more people's view on the clothes, it will be having an effect on the image of the clothes that you are intending to bring on. If you have different people's opinion and this thing eventually brings up something, it will be like, okay, I think this one can be generally accepted. So web scraping is just basically you extracting data from the internet into your workspace and you working on it. So it's not something very, and it's also easy to know. Yeah. Okay. Yes. The tools that I need to remember in Python, I think it is Beautiful Soup. Yes, you can use Beautiful Soup for, like, that is the name of the Python tool for web scraping. So you can use Beautiful Soup, you can use LXML, you can use Mechanical Soup, you can use Selenium too. Yes, you can use Selenium, which is also, and also ScrapPy. So there are a lot of tools for you to use, and which are easy, which are also efficient in web scraping analysis. So that is basically it.
All right, thank you. I would like to entertain more questions, but because of time, we'll have to stop here. But before we go on, I have a presentation to make. So
Hello, you're muted. We can't hear you.
oh, apologies. Okay, I was saying this event is powered by BincomDevCenter, and BincomDevCenter is a multi-location based training and development center for technology resources and technology solutions. And we're situated in various locations. First of all, virtually near you, we have locations at Lagos State, Oyo, Kano, Kaduna, Ogun State, Delta, and we have plans to expand to other locations. Some of our services include the Bincom Academy, the Bincom Tech Internship, the Bincom Tech Apprenticeship, the Bincom Community Events and Projects, the Light Space. I have the Bincom Global Tech Program, Emigrate, the Bincom Mentoring Platform, Labs by Bincom. So let's drill down to some of these services. First of all, we have the Bincom Academy, which is an intensive training program facilitated by BincomDevCenter. Each technology or application development class is typically 4 weeks of intensive training. So during this period, participants will go through the training curriculum for that knowledge track in a Montessori approach. So we have a couple of classes available. We have Python mobile app, PHP MySQL, we have foundation, graphics design, project management, IT system engineer, DevOps. We have the digital marketing class and so on. To see a full list of all classes available, kindly visit bincom.net/academy. And also pricing is also available when you visit that site. We have the Light Space, which provides helpful working workspace intended to encourage collaboration and drive innovations in the startup ecosystem. So we have spaces that are created and designed for various events like seminars, conferences, and get-together. And this Light Space is available in most of our locations. Virtually near you, we have at Yaba, we have at Oyo, Kano, Kaduna, Ogun State, and Warri. So to find a complete list of locations, kindly visit blog.bincom.net/campuses. We have the community events and projects, and these events are divided into 5. We have the masterclass, the meetups, idea sharing, explore on the move, challenge, and brainstorm. So the meetups is an example of the meetup. We have data science meetup, and the idea sharing. Under that, we have the Bincom ICT Career Talk, which holds every last Saturday of every month. So these are some of our meetups. We have the PHP meetup, cloud hosting, formerly Amazon Web Services meetup. We have the Angular meetup, digital marketing meetup, data science meetup, which is currently taking place now. We have the Laravel/Ye meetup and the DevOps meetup. So for our masterclass, we have the Bincom Startup School, Social Lender Digital Financial Services Masterclass, and the Technology Enhanced Learning EdTech series. And for idea sharing, we have the Bincom ICT Career Talk and the Emigrate Open Day. Then the next service there is the Bincom Global Tech Program, which is a solution to launch your tech career globally. And it is focused on 3 key pillars, which are learn skills, gain experience, and gain exposure. So if you're interested in learning tech, interested in pursuing a career in tech, you should definitely try this program out. And if the finance is going to be a problem for you, you don't have to worry about that because we have an income sharing agreement where you get to learn tech now and then you pay later. So I'm about to play a video that explains the Bincom Tech program and the income sharing agreement better. Sorry, just a moment. Sorry, can you hear the video?
The total cost of the Bincom Global Tech program for the period of 1 to 2 years is just 1.2 million naira. But you don't need to worry about that because it gets better.
Yes.
Various financing options to help you cover the cost of the program. So you don't need to have any money to even apply or be admitted to the program. One of the financing options that are available for this program is the income sharing agreement. What that simply means is that the company will sponsor your learning. So you would learn for the period of 1 to 2 years and you only start paying back when you get a job and you start earning your income after this program. This means that aside from skills, experience and exposure, the company is also willing to invest its own money on you. That's a total package. What are you waiting for? You need to go on our website, bincom.net/global-tech. You need to register and then launch your global tech career. I'm sure that the tech world, the tech industry is waiting for a great talent like you. Thank you.
All right, moving on. Which is pronounced immigrant. So it provides tech-enabled visa opportunities for people in tech, whether the technical or the business side of tech. It gives opportunities to live and work in countries like the UK, USA, Canada, and France. So to find out about service, you can visit bincom.net/immigrant open day. So these are some of the services for the immigrant tech-enabled visa pathway. They have the free package and you have the premium package. If you're interested, the first step you need to take is indicate interest at bincom.net/immigrant. Then the second step is request for immigrant service at blog.bincom.net/immigrant pricing. So the next service there is Labs by Bincom, which is a platform that enables you to start working on skills that you earned. If you're still a newbie in tech, and you want to work on real life projects to build your portfolio and also gain experience and exposure, this is a platform for you to do that. So to find out more about it, you can visit bincom.net/labs. So we have the MyCircle Ambassador program. BincomDevCenter Ambassador campaign is a partnership with MyCircle, bringing the ability for people to earn from their network and positive social influence. You get to earn 10% from BincomDevCenter for any of these services which you refer. For example, you earn 10% of the payments made by prospective Bincom Global Tech Program participants referred by you, which is 120,000 naira. So you can contact us, send us an email at bincomdevcenter@bincom.net. You can call the phone number displayed on your screen, or you can visit our site, bincomdevcenter.com. So if you have any questions or feedback regarding this presentation I made, you can always ask. All right, with that, I've come to the end of my presentation. I'm expecting questions or feedback. All right. In the absence of any questions or any feedback, I would like to thank our speakers, Taoheed, Abdulraheem, and Efe, for being with us today, and for all our participants for joining and getting to acquire this knowledge about data science lifecycle today. Once again, I appreciate you guys for making our time for being with us. And I would like to bring this session to an end. Thank you once again, and do enjoy the rest of your day and have a lovely weekend. Thank you.